Good morning, students. I'm Krina Dayani and I'm your chemistry teacher. In our previous lecture, we have discussed about some of the important terms related to our chapter, that is structure of atom. We have gone through some of the radioactive isotopes, that are alpha, beta and gamma particles. So today we are started with a fresh topic, that is called quantum numbers. So now our next topic will be quantum numbers. So what basically the quantum number is? Quantum number are the set of numbers which is used to define the shape and space of an electron in the outermost orbit of any atom. So what will quantum number will specify? It will specify the shape, size and the number of electrons in the orbit. So I am writing definition here. Quantum numbers are the numbers which specify number and position of electron in an orbit. It means the quantum numbers will basically tell us about the two things, that is first the number of electrons and second it will tell us about the position of electron in the orbit. Orbit is a circular path in which electron usually revolves. Now quantum number are classified in the four categories based on the different values. So we have four category of quantum number here. So next, quantum number are broadly classified into four categories. So here our first category is principal quantum number. Our second category is azimuthal quantum number. Our third category is magnetic quantum number. And our last category is spin quantum number. So these are the four categories in which the quantum numbers are basically classified. So here our first category is principal quantum number, second category is azimuthal quantum number, third category is magnetic quantum number and the fourth category is spin quantum number. So now students, we will deal with these four classifications one by one. So our first category is principal quantum number. What actually the principal quantum number are? Principal quantum number is discovered by Bohr and it automatically or usually tell us about the size, shape and energy of a shell. So we will start with our new topic, that what actually the principal quantum number are. So our first topic is principal quantum number. So what are principal quantum number? These are the quantum numbers basically discovered by Bohr. So our first point of consideration is these particles or these numbers are discovered by Bohr. Second, these numbers are usually represented by a symbol that is small n. These numbers are represented by small n. These numbers usually tell us about the energy, shape and the size of the orbital. What they are going to specify tells us about three things, that is shape, size and energy of shell. So these quantum numbers will going to specify these three considerations, that is shape, size and energy of the particular shell. So these are the three basic points about the principal quantum number. Now principal quantum number can be from any value starting from 1 to infinity. So we will substitute different values and get the maximum number of electrons in a particular shell. So now we have fourth consideration about the principal quantum number, that is its value will be represented as a n and it may be 1, 2, 3 and so on. Now what actually happens, if the distance will increase, n will increase, the distance of the electron from the center of the nucleus will going to increase. So our next point is n value if get increased, the distance from the center of an electron to the outermost shell will automatically going to increase. So what we will get, we have R1, R2, R3. These are the distances of electron from center to the outermost shell. It will keep on increasing. Now next point of consideration is when n value increases, the energy of the electron will keep on increasing. So we may say that E1 has less energy and then E2, then E3 and so on. So this is about the distance and this thing is about the energy. This is about the distance and this thing is about the energy. So it is the basic things about the principal quantum number. Now we want to specify what the n 1, 2, 3, 4 usually known as. So what we can say about the principal quantum number, that if I write n equal to 1, n equal to 2, n equal to 3 and n equal to 4, if we want to specify the principal quantum number by 1, 2, 3, 4, we may call it as n equal to 1 is called first shell, n equal to 2 is known as second shell, value of n equal to 3 is known as third shell and value of n equal to 4 is known as fourth shell. So we can write it as in the number form, that is 1 first shell, second shell and n equal to 3 is the third shell and so on. But for the simplicity, we have designated these terms by the few alphabetical symbols. So if we have n equal to 1, we may call it as a K shell. If I have n equal to 2, I can call it as L shell. If we have n equal to 3, we can call it as M shell. And if we have n equal to 4, we can call it as N shell. So here it is a few alphabetical representation of the 4 quantum numbers. Now what we want to do, we want to calculate the maximum number of electrons in a particular shell. So for counting the maximum number of electrons in a shell, we have a formula, that is 2n square. So now we want to calculate the maximum number of electrons. we have maximum number of electron and we have a shell, and here we have a value of n. Now what we will do, we will write the value of n as a 1, 2, 3 and 4. We have 4 values of n and we have the 4 shells corresponding to it, that is K shell, L shell, M shell and N shell. Now maximum number of electrons can be calculated by the formula 2n square. So we will calculate the maximum number of electrons in these shells. So what we will get here, K correspond to 2 into 1 square, that is 2, again 2 into 2 square, that is equal to 8, 2 into 3 square, that is equal to 18, and 2 into 4 square, that will be equal to 32. So these are actually the maximum number of electrons according to principal quantum number in a particular shell of an atom. Now these are the basic terms related to principal quantum number, and the last thing we want to specify about these number is the angular momentum. So in case of principal quantum number, we have last term, that is angular momentum. Angular momentum for the principal quantum number is basically given by the formula mvr equal to nh upon 2 pi. Here m is the mass of the electron, v will be the velocity, r will be the radius of an atom, n has been the counting from 1 to infinity, and h is the constant known as Planck's constant. So the angular momentum will be given by the formula mvr equal to nh upon 2 pi, and n can be vary from 1 to infinity. So it is all about the principal quantum number. Now we are proceeding to our second set of quantum numbers, that is azimuthal quantum number. If someone wants to copy it, please copy it now. So now discussing about our second set of quantum numbers, we have second category, that is azimuthal quantum number. So azimuthal quantum number has been discovered by Sommerfeld, and these are basically represented by a symbol L. So our first point of consideration here is it is discovered by a scientist named Sommerfeld. Second, azimuthal quantum number is basically represented by a symbol small l. Represented by a symbol small l. Now, our third property is these quantum numbers will need to specify the subshells in a shell. So, what we will get about the azimuthal quantum number, we will get the idea of subshells from here. Next point is, it tells us about subshells of an atom. Another name for azimuthal quantum number is angular quantum number, secondary quantum number, and subsidiary quantum number. So, another name for azimuthal quantum number is, it is known as, it can be known by the three names. First, secondary quantum numbers, subsidiary quantum number, and the last, angular quantum number. So, the azimuthal quantum number is basically known by the three names, that is secondary quantum number, subsidiary quantum number, and the angular quantum number. These are the another three names for azimuthal quantum number. Now, what azimuthal quantum number will tell us? It will tell us about the subshell of an atom, and it is basically denoted by the symbol L, and its value may vary from 0 to n-1. So, our next point of consideration is value of azimuthal quantum number, that is L, may be from 0 to n-1. Now, what we have considered here, suppose we have shells K, L, M, N, and we know that value for N will be 1, 2, 3, 4, but if I talk about the azimuthal quantum number, these will start from 0 to n-1. So, what we have to consider? We have to consider its value from 0. So, if I talk about subshells, it may start from 0 and it may be 0, 1, 2, 3. And what will we get the value of L here? We have in 0 we have 0 value. In case of 1 we will get 0, 1. In case of 2 we will get 0, 1, 2. In case of 3 we will get 0, 1, 2, 3. So, this is a set of L values for the azimuthal quantum number. Now, we will discuss what these subshells are called. If I tell L equal to 0, 1, 2, 3, we can call the name of a shell as for value of L equal to 0, the shell is called S shell. For value of P, it is called P shell. For value 2, it is called D shell. And for the value of 3, it is called F shell. So, it can be represented by the symbol SPDF, and it is actually the subshell. So, if we have value of L equal to 0, we will specify as a S. SPDF is an abbreviated form of the number of shells, that is, for S we can call it as a sharp, P is known as a principal, D is known as degenerate, and the F shell is basically known as fundamental. So, these are the terms we have used for defining the subshell of an atom, that is S, P, D and F. S is for sharp, P is for principal, D is for degenerate and F is for fundamental. So, here are the categories of SPDF, that are subshells, and here are the category of shells, that is KLMN. So, I hope it must be clear to you that what are shells and what are subshells. Now, for the azimuthal quantum number, we want to calculate the maximum number of electrons. So again, we have calculated maximum number of electrons for azimuthal quantum number, and it can be calculated by using the formula 2 2l plus 1. Now for different values of SPDF, we will calculate the maximum number of electrons. Now we have different values of L, that is 0, 1, 2, 3, and what we want to calculate, we have to calculate the maximum number of electrons. Here we want to calculate maximum number of electrons. So we will calculate this by using this general formula, that is 2 into 2l plus 1. So what we will get? We will get 2. 2l plus 1 means 2 into 0 plus 1. So maximum number of electrons will be 2. Now for 1, we will have 2 into 2 into 1 plus 1. That is equal to 2 plus 1 plus 1, 3. 3 into 2, 6. Now we will substitute 2. 2 into 2 plus 1, 2 into 2 4, 4 plus 1 5, and 5 into 10 we will get 10 electrons. For value of 3, 2, 2 into 3 plus 1, what we will get? 3 into 2 6, 6 plus 1 7, and 7 into 2 14. So maximum number of electrons in the case of azimuthal quantum numbers are calculated by 2 into 2l plus 1. So what we are getting here, for azimuthal quantum number, we have the values 2, 6, 10 and 14, which will give us the maximum number of electrons. Now the last term we will discuss about the azimuthal quantum number is the angular momentum of this number. So the angular momentum for azimuthal quantum number is given by h upon 2 pi under root L plus 1. So it is the formula for calculating the angular momentum for azimuthal quantum number. So students, today in our lecture we have discussed about the set of two quantum numbers, that is principal quantum number and azimuthal quantum number. Now we are left with our two more quantum numbers, that is spin quantum number and magnetic quantum number, that will be discussed in our next class. Thank you so much and have a nice day.